My name is Ashish Udgave. I am working as Assistant Professor in Department of Mechanical Engineering, Sharad Institute of Technology, College of Engineering, Yadram, Itzelganji. I am welcome to all in the lecture of Equilibrium, module number 2. In last video, we have covered the concept of equilibrium, free body diagram, Lami's theorem, and to solve the problems on Lami's theorem. Today, in video number 10, we are going to solve the problems on Lami's theorem. First problem, check whether a wire having capacity of 800 Newton can lift a load of 800 Newton if it is attached as shown in figure. Refer figure 4.7.9a. Solution, draw the FBD of the figure for better understanding of further simplification. Now, let TAB be the tension in string AB and TBC be the tension in string BC. Now, the angle between TBC and 800 Newton is 15 plus 90 degree is equal to 105 degree. Similarly, the angle between TAB and 800 Newton is 40 plus 90 is equal to 130 degree. And the remaining angle is 360 minus 105 minus 130 is equal to 125 degree. That is, angle between TAB and TBC is 125 degree. Now, by applying Lami's theorem, we get TAB divided by sine of 105 is equal to TBC divided by sine of 130 is equal to 800 Newton divided by sine of 120. Now, equating TAB divided by sine of 105 is equal to 800 divided by sine of 125. We get TAB, that is tension in chain AB, is equal to 943.34 Newton. And again equating 800 divided by sine of 25 is equal to TBC divided by sine of 130. Therefore, we get TBC is equal to 478.30 Newton. Now, next question. A weight of 200 Newton is attached by strings. Calculate the tension in the string. Here, first figure shows problem figure and second figure shows solution of the figure. Weight of the body is 200 Newton, which is acting in downward direction. Let T1, T2 be the tension in the strings. Now draw a parallel line to the ceiling Therefore, we get angle between weight and T1 is equal to 120, which is equal to 30 plus 90 is equal to 120. And angle between T2 and W is equal to 60 plus 90 is equal to 150. Therefore, remaining angle is equal to 3, that is angle between T1 and T2 is equal to 360 minus 120 minus 150. Therefore, we get angle between T1 and T2 is equal to 90 degree. Now, by applying Lami's theorem at point O, we get sine T1 divided by sine of 150 is equal to T2 divided by sine of 120 is equal to 200 divided by sine of 90. Now, equating T1 divided by sine of 150 is equal to 200 divided by sine of 90, we get T1 is equal to 100 Newton. And again, taking T2 divided by sine of 120 is equal to 200 divided by sine of 90, we get T2 is equal to 173.2 Newton. Therefore, answer of this problem, T1 is equal to 100 Newton and T2 is equal to 173.2 Newton. Next question. A sphere weighs 1200 Newton. It is supported by two planes at 35 degree and 50 degree to the horizontal respectively. Calculate the support reactions. From the given data, draw a figure for better understanding and further simplification. In this figure, a sphere of weight 1200 is kept in the notch of inclined planes of 35 degree and 50 degree. Now simplify the above figure as shown in figure B and draw FBD as shown in figure C. Since weight of the figure is acting in downward direction, therefore 1200 Newton is acting in downward direction. At point A, there is support reactions or normal reaction which is equal to RA. As angle between inclined plane and horizontal plane is 35 degree and 50 degree, therefore angle between RA and horizontal plane is 55 degree and angle between RB and horizontal plane is 40 degree. Therefore, from figure C, angle between RA and 1200 Newton is equal to 55 plus 90 is equal to 145. Angle between RB and 1200 Newton is equal to 40 plus 90 is equal to 130, and the remaining angle is equal to 360 minus 145 minus 130 is equal to 85 degree. That is, angle between RA and RB is equal to 85 degree. Now, by Lami's theorem, we get RA divided by sine of 130 is equal to RB divided by sine of 145 is equal to 1200 divided by sine of 85. Therefore, we get R equating RA divided by sine of 130 is equal to 1200 divided by sine of 85. Therefore, we get RA is equal to 922.76 Newton. Also, by considering RB divided by sine of 145 is equal to 1200 divided by sine of 85. Therefore, we get RB is equal to 690.92 Newton. Now, next question. A sphere having 300 mm as a radius and 1000 Newton as a weight resting against a wall and an inclined plane as shown in figure A. Calculate the reactions given by the wall and the plane. Let A be the point of A and B be the point of contact between sphere and vertical wall and inclined wall respectively. Now, redraw the given figure A as shown in figure B for further simplification. As at point A, a reaction is horizontal because supporting surface is vertical. Therefore, RA will pass through point O. Weight of body is acting in downward direction since weight of body is 1000 Newton, and RB will be along the RB should be perpendicular to the supporting surface. Therefore, angle of RB with respect to horizontal is 70 degree. All the three forces, namely RA, RB and 1000 Newton, are passing through a single point, that is point O. Now consider FBD at figure C. We know that angle between RA and 1000 Newton is 90 degree. Angle between RB and horizontal is 70, and angle between RB and 1000 Newton is 70 plus 90 is equal to 160 degree. Therefore, remaining angle is equal to 360 minus 90 minus 160 is equal to 110 degree. That is nothing but angle between RA and RB is equal to 110 degree. By applying Lami's theorem, we get RA divided by sine of 160 is equal to RB divided by sine of 90 is equal to 1000 divided by sine of 110. Now, by taking RA divided by sine of 160 is equal to 1000 divided by sine of 110, therefore we get RA is equal to 363.97 Newton. Also, by taking RB divided by sine of 90 is equal to 1000 divided by sine of 110, therefore we get RB is equal to 1064.18 Newton. Equilibrium of connected bodies. A system of connected flexible cables shown in figure is supporting two vertical forces of 200 Newton and 250 Newton at points B and D. Determine the forces in various segments of the cable. Let T1 be the tension in chain DE, T2 be the tension in chain BD, and T3 with the tension in chain BC. Now, angle between T3 with respect to vertical is 30 degree and angle between T2 with respect to angle between T2 and 200 Newton is 60 degree. Same angle between T1 with respect angle of T1 with respect to horizontal is 45 degree. Now free body diagram of points B and D are shown in figure B. Let the forces in members be shown in figure. Now applying Lami's theorem to the system of forces at D, we get T1 is equal to 224.1 Newton and T2 is equal to 183 Newton. Since at point D there are maximum 3 forces are there, therefore we can apply Lami's theorem. Now consider the system of forces acting at B. As there are 4 forces, therefore we cannot apply Lami's theorem at point B. Now equating it to 0, that is equating summation fx to 0 and summation fy to 0, we get, first of all we apply summation fy is equal to 0, gives T3 is equal to 336.6 Newton, and applying summation fx is equal to 0 gives T4 is equal to 326.8 Newton. Therefore answer of this problem, T1 is equal to 224.1 Newton, T2 is equal to 183 Newton, T3 is equal to 336.6 Newton and T4 is equal to 326.8 Newton. A wire rope is fixed at 2 points A and D as shown in figure A. Weights of 20 kN and 30 kN are attached to it at B and C respectively. The weights rest with portions AB and BC inclined at 30 degree and 50 degree respectively to the vertical as shown in figure. Find the tensions in segment AB, BC and CD of the wire. Determine the inclination of the segment CD to the vertical also. Let tension between segment AB be T1, tension between segment BC be T2, tension and the tension between segment CD be T3. Now figure B and C shows free body diagram at point B and C respectively. The angle of force, the angle of T1 with respect to vertical is 30 degree and angle between T2 and 20 kN is 50 degree. Angle between T2 with respect and vertical is also 50 degree, which is shown in figure C. Now figure B and C shows free body diagrams of points B and C. Applying Lami's theorem to the system of forces at point B, we get T1 is equal to 44.80 Newton, 80 kN and T2 is equal to 29.2 kN. Now consider the equilibrium of forces at point C. Applying summation fx is equal to 0, we gives T3 sin of theta is equal to 22.4. Let we will call this as equation number 1. And summation fy is equal to 0 gives T3 cos of theta is equal to 11.20. Let we will call this as equation 2. From equation 1 and 2 we get theta is equal to 63.43. Substituting this value in equation 1 we get T3 is equal to 25.04 kN. Therefore answer of this problem, T1 is equal to 44.80 kN, T2 is equal to 29.2 kN and T3 is equal to 25.04 kN. Next question. Two identical cylinders each weighing 500 Newton are placed in a trough as shown in figure. Determine the reactions developed at contact points A, B, C and D. Assume all points of contact are smooth. The free body diagram of two cylinders are shown in figure B and C. consider the equilibrium of cylinder first. Now, since RA is at right angles to the plane, it makes an angle of 60 degree with respect to horizontal. That is 30 degree with respect to vertical. And RB is parallel to the plane since the cylinders are identical. Thus, RA and RB at right angles to each other. Therefore, weight of both the cylinders are acting in downward directions as both the cylinders are identical. Therefore, the radius are also identical, that is radius are also same. RD is acting in horizontally right direction since supporting surface is vertical. RA and RC are perpendicular to the supporting surface. The as in angle between inclined plane and horizontal plane is 30 degree. Therefore, RA and RC makes 60 degree to the horizontal. The line joining point 1 and 2, that is nothing but RB, makes an angle 30 degree with respect to horizontal. Now considering equilibrium of cylinder first and taking summation of forces normal to the plane is equal to 0, that is summation Fy is equal to 0, gives Ra is equal to 433 Newton. And forces, summation of forces parallel to the plane is equal to 0, that is summation Fy gives Rb is equal to 250 Newton. Now consider the equilibrium of cylinder 2. At cylinder 2 there are 4 forces, therefore we cannot apply Lami's theorem. Rd is horizontal since the line of contact is vertical. Rc is normal to the plane and Rb is parallel to the plane. Now applying summation Fy is equal to 0 gives Rc is equal to 721.7 Newton. And applying summation Fx is equal to 0 gives Rd is equal to 577.4 Newton. Therefore, answer of this problem, Ra is equal to 433 Newton, Rb is equal to 250 Newton, Rc is equal to 721.7 Newton, and Rd is equal to 577.4 Newton. Please note that this video is prepared for academic use only to solve the problems on Lami's theorem for UG students only. Thank you. Thanks a lot. For any query, please feel free to contact me on mail or on mobile. Thank you.